Good evening, everyone. Today we're going to do the remaining sums of Bayes' theorem. As you can see, this is solution for the first question. Let's first read the question. A urn contains 5 red and 5 black balls. A ball is drawn at random. Its color is noted and returned to the urn. Moreover, 2 more additional balls of the same color is put into the urn. Then a ball is drawn. What is the probability that the second ball is a red? The second ball is a red and they haven't told us what the first ball is. So there could be two cases to this. A first ball can be a red, the first ball can be a black. If the first ball happens to be a red ball, then you keep that ball back and then you put 2 more black ball of the same color. Likewise for the second one also. Let A be the second ball being red. Let E1 be the first ball is a red. Let E2 the first ball is black. Throughout the exercise, I've assumed everything in terms of A, E1 and E2. So then you will be able to connect it to the theorem easily. Do not use different variables, it may confuse sometimes. So let A be second ball being red. E1 is the first ball red. As per the question, if you take a red ball out, the red ball is put into the urn back and 2 more balls of the same color is put into the urn. So probability of drawing the first red ball is P of E1, which is 5 out of 10. Probability of drawing the first ball black is P of E2, which is 5 by 10. Now A is drawing a red ball after E1, which means the first is a red ball and then you take a red ball again. If first is a red ball, you put that ball back and you put 2 more red balls. So total number of red balls is 7 now and total balls in the urn becomes 12. So 7 out of 12 will be the total probability of drawing a second red ball given the first is also red. Now A given E2 is drawing the second ball red given that the first ball is a black. If the first ball is black, you put that ball and 2 more black balls. So count will increase, the total balls count will increase, but the black ball strength will remain the same. The red ball strength will remain the same. So A given E2 will be 5 by 12. So probability of drawing a second ball red could be drawing a red ball and then taking the second red ball, or drawing a black ball and then taking a red ball. So this is a total probability question. If this was been a Bayes' theorem question, they would have added one more line to this question. If the second ball is a red, what is the probability the first ball is also a red? Or what is the probability the first ball is not a red or maybe black? So this is how you have to distinguish the Bayes' theorem with that of the total probability question. So the next question that I'm going to do is question number 13. The probability that A speaks truth is 3 out of 5, 4 out of 5. A coin is tossed, A reports that head appears. The probability that there was a head. So the probability that there was a head. Let E1 be the probability that it is a head. Let E1 be that there was a head, probability of getting a head. Let E2 be not getting a head, so just getting a tail. A coin tossed only once, so E1 is probability of getting head, E2 is probability of getting tail. So P of E1 will be 1 by 2 and P of E2 is also 1 by 2. Let A be the event where A reports it's a head. Reporting it's a head. So A given E1, meaning A reports it's a head after getting head. Because E1 is an event of getting head and now A says it's a head, which means A speaks the truth. So therefore the chances of A speaking the truth is 4 out of 5. And A given E2, it's not a head, but he says it's a head. E2 is getting a tail. So A given E2 is, he says it's a head, but it's the actual outcome is a tail. So then he's lying. So the chances is 1 by 5. Now what is being asked here? A reports that the head appears, then what is the probability? So you can add the word what here in order to understand, because what is the probability that it's a head? So it's E1 given A, P of E1 given A, which is Bayes' theorem. P of E1 into A given E1 by P of A. So we first have to find the total probability, which is 1 by 2 into 1 by 2 into 4 by 5 plus 1 by 2 into 1 by 5. And then the numerator will be P of E1 given A will be 1 by 2 into 4 by 5 divided by 1 by 2 into 4 by 5 plus 1 by 2 into 1 by 5. Next we take question number 12. A card from a pack of 52 is lost. From the remaining cards, 2 cards are drawn and they are found to be both diamonds. Find the probability that the lost card be the diamond. So let E1 be the lost card is a diamond. Lost card is a diamond. And E2, the lost card is not a diamond. So P of E1 is 13 by 52, which is 1 by 4. And P of E2 will be 3 by 4, because it will be 39 by 52. Because E2, the last card, is not a diamond. So it could be any card other than a diamond. So from 52, if you subtract 13, you get 39. 39 by 52, simplify 3 by 4. Or you can take it as 1 minus 1 by 4 also, even then it is 3 by 4. So P of E1 is 1 by 4, P of E2 is 3 by 4. A, 2 cards drawn and found to be both diamonds. So P of A given E1 is, the last card is a diamond, and then you take 2 cards which is also a diamond. So now we have only 12 diamond card because one is lost. So 12 C2 by 51 C2. And A given E2, which means the first card lost is not a diamond, then you take 2 cards which is a diamond. So 13 C2 by 51 C2. So now what is asked here? They want us to find E1 given A, which is base P of E1 into A given E1 by P of A, which is 1 by 4 into 12 C2 by 51 C2 divided by 1 by 4 into 12 C2 by 51 plus 3 by 4 into 13 C2 by 51 C2. Now simplification of 12 C2 is 12 into 11 by 1 into 2 by 51 into 50 by 1 into 2. So 1 into will directly get cancelled. So 12 into 11 by 51 into 50. Like that 13 C2 will be 13 into 12 by 51 into 50. So this way we can find the answers for this question. Question number 11. A manufacturer has three machine operators A, B, C. The first operator A produce 1% of defective, whereas the other two operator B and C produce 5% and 7% of the defective items respectively. A is on a job for 50% of the time, B is on job for 30% of the time, and C is on job for 20% of the time. A defective item is produced. So a defective item is produced. When a defective item is produced, it could be an item produced by machine A, or it could be by B, or it could be by C. So that is our total probability. What is we need to find? We need to find what is the probability that it is by product. It was produced by product A. So this defines our E statement. This is our A statement. So E1 is the product produced by machine 1, or machine A is the product produced by machine A, and E2 is the product produced by machine B, and same for E3, product produced by machine C. A is on job for 50% of the time, so that means machine A produces 50% of the output. So P of E1 is 50 by 100. P of E2, B is on time for 30% of, B is on job for 30% of the time. So B produces 30% of the output. And C is on job for 20% of the time. So C produces 20% of the output. Out of the output produced by machine A, 1% is defective. So A given E1 will be defective item produced by the product of machine A, or defective from machine A. As per data is 1 by 100. And P of A given E2, it's 5%, which is 5 by 100. P of A given E3 is 7 by 100. Now, what is P of A? P of A is producing a defective item, which could be from machine A into its defective, plus machine B and its defective, and then machine C and its defective. So this is your total probability, which is 50 by 100 into 1 by 100, and then 30 by 100 into 5 by 100, and then 20 by 100 into 7 by 100. So this is our total probability, and what we need to find is E1 given A. I think you all know how to deal with this now. So P of E1 into A given E1 divided by P of A. Question number 14. If A and B are two sets such that A is a subset of B and P of B is not equal to 0, which of the following is correct? So let us find the reason why each one is not correct or otherwise. So first says P of A given B is P of B by P of A. So P of A given B is P of A intersection B by P of B. So the first and foremost, the denominator is wrong. 2A intersection B will be P of A because A is a subset of B. Hence, it should be P of A by P of B, not P of B by P of A. So that is the reason the first one is incorrect. Now coming to the second one. Is P of A given B is less than P of A? Well, P of A given B is P of A intersection B by P of B. P of A intersection B by P of B. P of A intersection B is P of A because it's a subset by P of B. Now, I'm not very sure about whether it's lesser or greater because it's in a probability form. Let's make it to the cardinal number form. N of A by N of S will come, divided by N of B by N of S will come. So eventually N of S will get cancelled. So you get N of A by N of B. Okay, so here it is N of A by N of B. Whereas here it is N of A by N of S. The N of S value will be definitely bigger than N of B value, because that's just the sample points. So hence, this answer will be lesser than this answer. So this would be the greater, so it should be the other way around. Hence, this is also not right. So the last option that we have is this. Yes, it can be greater or greater than equal to, because it's subset. So C is the answer for this. So the next question is question number 5. 5 and the example question, which is an HIV question, is equally important. So when you learn 5, also learn that example along with this. Now, and also apply the same concept in that question. A laboratory test is 99% effective in detecting a certain disease when it is in fact present. However, the test yields false result for 0.5% of the healthy percent tested. It's 0.5 percentage, 0.5 by 100, that's why it's 0.005 in the brackets. So we can leave it as of now. 0.5% test yields a false result. If 0.1 percentage of the population actually has a disease, so of the larger population, 0.1 percentage have the disease. What is the probability that a person has the disease given that the test is positive? So let's the test be positive, be A, and the person having the disease be E. So I'm writing all the information in the side, so it's easy to connect with the question. So P of E1 is probability of selecting a person who actually has the disease. So this is E1. So out of that, 0.1 percentage only have disease. 0.1 percentage is 1 by 1000. So P of E2, E2 is complement of E1 normally. So it is 1 minus 1 by 1000. So 999 by 1000. Now A is the test is positive. Test result is positive. The test result is positive. Now A given E1 is E1 is having the disease, A is the test is positive. So the test shows positive result given that he has a disease. So that means the test shows the correct, it was able to detect the disease. So as per the data given, 99 percentage is that. And whereas A given E2 will be, the test result is positive, but the person is not positive. So that means it's a false result. So as per the data, it's 0.5 percentage, which is 5 by 1000. 0.5 percentage, which is 0.5 by 100. So you multiply by 10, so it's 5 by 1000. So this is how we find E1, E2, A given E1 and A given E2. And what they want us to find is P of E1 given A. So all that events that I defined over here, I've taken those values in the blackboard. So P of E1, P of E2, P of A given E1 and P of A given E2. So it's 1 by 1000 into 99 by 100 divided by P of A, which is the total probability. See here the denominator is 1 followed by 5 zeros. Here 1 followed by 5 zeros, whereas here 1 followed by 6 zeros. So LCM will be 1 followed by 6 zeros. So here you get a 0. And therefore if you simplify, you will get 990 by 990 plus 999 into 5. This is 999 into 5. So if you simplify that, you get 445, 4495. So 990 by 990 plus 4495, which is 990 by 5985. Simplify this, you get 22 by 133. So from miscellaneous exercise, let's pick up the base question and do it. So question number 3 is Bayes' theorem. 5% of men and 0.25% of the women have grey hair. A grey-haired person is selected at random. What is this? What is the probability of this person being a male? So you select a person and he has a grey hair. What is the probability that he is a male? So selecting a grey hair person is A. Selecting a grey hair male is your is what they ask. So P of E1 given A, where A is selecting a grey person, E1 is selecting a male. So E1 is selecting a male. There is equal number of males and females. So half. So P of E1 is half. P of E2 is also half. And then P of A is selecting a grey hair person, which could be a male, which could be from male section or from the female section. So P of A is our total probability, which is P of E1 into A given E1. And what is P of A given E1? Which is selecting a male having a grey hair, which is 5 by 100. And P of A given E2 is 0.25 by 100. So P of E1 into A given E1, well, I'll better write it down. P of A equals P of E1 into P of A given E1 plus P of E2 into A given E2, which is 1 by 2 into 5 by 100 plus 1 by 2 into 0.25 by 100. And what they want us to find, E1 given A. So this will come in the numerator divided by the total probability. So that is question number. So next base is question number 12. Suppose we have 4 boxes A, B, C, D containing colored marbles as given below. So box A contains 1 red, 6 white and 3 black. So total 10. Box B contains 10 again. Box C contains 10 again. And box D contains 10. One of the box is selected at random and a single marble is drawn from it. If the marble is red, what is the probability? It is from A, B and C. So this is actually 3 subdivisions. So what is A here? Selecting a red marble. So E1 is selecting box A. A is selecting a red marble. A given E1 is selecting a red marble from box A. So A given E1 is 1 by 4. P of E2 is 1 by 4. P of E3 is 1 by 4. P of E4 is also 1 by 4. P of A given E1, A is selecting a red ball from box 1. Contains only 1 red, so 1 out of 10. So total probability, that is total probability of drawing a red ball from whichever box it may be, is as usual P of E1 into A given E1. So on till P of E4 into A given E4. And the numerator, we will have to deal it separately for box A and box B and box C. Okay? So that's question number 12. Question number 16. Bag 1 contained 3 red and 4 black balls. So bag 1 and bag 2. Bag 1 contained red number 3, black number 4. Bag 2 contained 4 red and 5 black. So total 7 and total 9. One ball is transferred from bag 1 to bag 2 and then a ball is drawn from bag 2. So in normal course itself we transfer a ball from bag 1 to bag 2 and then a ball is taken from bag 2. The ball so drawn is found to be red in color. So this is our total probability, drawing a red ball. Find the probability that the transferred black ball is a black. So E statement is this. E is a transferred ball is a black. So let E1 be the probability of the transferred ball being black. From where it is transferred? From bag 1 to bag 2. How many black balls bag 1 contain? 4. So 4 out of 7. So if E1 is transferring a black ball from bag 1 to bag 2, E2 is normally the complement of that, which is 3 out of 7 transferring a red ball. Now what is A? A is selecting a red ball. A is selecting a red ball from bag 2 after the transfer. Selecting a red ball from bag 2 after the transfer. Chalo. Now A given E1 is transferred ball is black and then you select a red ball. Okay, so the transferred ball is black. So when the transferred ball is black, the black ball count will increase. The black ball count will increase. So black ball will become 5. The total will become 10. So this would be, oh, transferred ball is black, so I have to correct there. Even the transferred ball is black, so black will become 6, red will remain 4. So A is taking a red ball, which is 4 out of 10 now. Whereas A given E2, the transferred ball is a red, so red will become 5 and the total will become 10. So this is A given E1 and A given E2. P of A will be 4 by 7 into 4 by 10 plus 3 by 7 into 5 by 10. The numerator of this is this one because it is that, no, sorry, the first one. Probability of transferring a black ball and then taking a red ball. So the numerator will be 4 by 7 into 4 by 10. Assuming that the chances of a patient having a heart attack is 40%. It is known that the meditation and yoga can reduce the risk of the heart attack by 30%. Prescription of drug reduces this by 25%. So here, if yoga and meditation is practiced, the risk reduces by 30%, which means the risk prevails for 70%. Likewise, taking the drug will reduce the risk by 25%. So risk exists to an extent of 75%. At a time, a patient can choose any one of the two options, which means he can either go for meditation yoga or he can use drugs with equal probability. So what is the chance of selecting one of the two options? 1 by 2. It is given that after going through one of the two options, the patient is selected, suffers a heart attack. So after going through this also, he is get heart attack. Okay? So probability, this is our A now. Find the probability that the patient followed a course of meditation and yoga. So this is E. So E1 is practicing yoga and meditation or going for this option is 1 by 2 because equal chances. The other one is also 1 by 2. A is suffers heart attack. Suffers heart attack. Right. After taking meditation and yoga, if he gets heart attack, how many, the 40% of the section only get heart attack. And out of 40%, if you practice yoga and meditation, the risk reduces by 30%, but then risk prevails for 70%. So P of A given E1 is 40% into 70%. And P of A given E2 will be 40% into 75%. The 75 because I already told you yoga reduces the risk by 30%, so 70% risk still exists. Again, meditation reduces the risk by 25%, so risk still exists for 75%. So this 40% section of people get heart attack. Out of this 40%, 70% is those who practice yoga still get it. So this is A given E1 and A given E2. And likewise, what they want us to find is E1 given A, and you go according to that. The formations are over with this. Try them and practice more base theorem questions based on this.